right. So today we are going to take parametric equations and we're going to apply it to some physics concepts, or really one physics concept, okay? Projectile motion, okay? Basically, when we have a set of parametric equations, we have an equation for x describing what the horizontal movement is, and we have an equation for y to describe what the vertical movement is. This allows us to find a lot of different information about this movement as opposed to just being stuck to vertical, okay? When you guys did projectile motion in Algebra 2 with parabolas, you really only knew information about the height, okay? Well, now with a set of parametric equations, we know something about the distance, the horizontal distance, and we know something about the height, okay? So this is always going to be how we're going to set it up. If something is projected into the air, okay, let's talk about how can we project things into the air. We could drill them. What else? We could kick a ball. We could shoot a cannon. Catapult. Lots of possibilities here. Okay. Yes.
Are we going to do dropping anything?
No. Because dropping would only, that would be like a one-dimensional type of movement, and we're going to focus on like the 2 dimensions, okay? The horizontal and the vertical, okay? Great question, okay? So first of all, what do you think T is going to stand for? Time. Time, and time's going to be in seconds, okay? What do you think this V naught stands for? What did you say, Elon? Initial velocity. Ugh. Okay. Since we have this 16 right here, we're using gravity as 32, okay, because that's 1/2 gravity. I just know that that's how they make the equation. So those of you in a physics class, if our gravity is -32, what units are we talking about? You know? Because you're usually using -9.8, which is meters per second squared. Okay? We're in feet per second. H naught. Okay? H naught is initial height. Okay? Notice how the initial height is only in the y equation because it's a vertical measurement. Okay? Well, then we have theta. What do you suppose theta, the angle, is going to represent? The angle in which it's projected. Okay? I'm kicking the ball at a 30-degree angle. It lifts off the ground at a 30-degree angle. Okay. There's going to be some soccer problems that we get to look at. Just pay attention to me, soccer boys. Okay. So what we're going to do is we're going to go through an example with some different types of questions I could ask with this. Okay. And then I'm going to give you a worksheet. Yay, worksheet. And we'll go through an example together, okay? All right. What I need you to write down is whatever you need to from this. So a football is kicked with an upward velocity of 30 feet per second at an angle of elevation of 55 degrees. Consider the position of the ball at any time t if air resistance doesn't matter. There's no wind. That doesn't happen here. Okay. Although it's very still outside this morning, it's a little eerie.
Storms coming. Storm.
I know.
Ah, good one.
I see a number, 30 feet per second. What? What's initial velocity?
What are you talking about? It says velocity.
30 feet per second is our initial velocity. Okay? I see 55 degrees.
That has to be something.
But you all are being entertained by them. Okay? T is always going to be your variable. It's something that we're going to be able to solve for. Okay, but there's a number missing up there. What is our initial height? 0. Why is our initial height 0? Because our football is on the ground. Okay? Now, if this were a punter, okay, it would have, your initial height might be a couple feet, but since he's going to kick a field goal, the football's on the ground. Okay? That's what I have. Right? They hold the football on the ground. Okay? So, let's set up the parametric equations. This is always going to be your first step. Once the information is given, set up your parametric equations. Okay? So you wrote down the setup on that first slide. X equals V naught cosine of theta t. So x equals our initial velocity cosine of our angle times t. You see why you need a calculator for today? Yes, thank you, Grace, for asking that question. Do we need a calculator in degrees? Yes, you do. Okay. Y is then going to be negative 16t squared, that doesn't change, plus V naught sine of theta t, and then we have plus our initial height, but since our initial height is 0, we do not need to worry about it. Now, I am going to ask you a variety of questions, and we are going to have to think about, do I need to use the x equation? Do I need to use the y equation? What type of word is going to tip us off or not word, but what kind of question are we going to answer if we're going to use the x? Okay, maybe how far will it go, at what time? Anything that deals with horizontal movement, we're going to use x. Anything that deals with vertical movement, we are going to use y. Okay? So my first question for us here, when will the ball hit the ground? Write it down. When will the ball hit the ground? So first of all, turn to your pod. Are we going to use x or are we going to use y?
Why?
Okay, well, when I said turn to your pod, I kind of thought that you would talk quietly, but some people yelled. Which equation are we going to use?
Why?
Y, okay. Since I'm talking about hitting the ground, that means that our vertical height is 0. So what we're going to do is we're going to take our y equation And we are going to set it equal to 0 because that means our height is 0. Okay, now here's the deal. Since our initial height is 0, we have two terms over here, both have what in common? Okay, we have a quadratic set equal to 0. We know we're going to get two answers, okay? One of them is t equals 0. Well, we knew that because it begins at the ground. This is the one you need to solve. Negative 16t plus 30 sine of 55 equals 0. Please do that in your calculator and compare it to your neighbor. Let's see what time this happens. Sorry, I'll move it. Yeah, that's not right
Dude, that's actually pretty close.
Okay, so this is a graph of what's happening. I put this into our calculator. Here we are beginning at 0, right? And then we are trying to find this point right here. When does it hit the ground? Okay. So Miranda, what time did you all find? Brandon, you put it in your calculator.
Yeah, I am.
Okay. Are you in degree mode?
Yeah.
Okay. So did you take 30 sine of 55 and then divide it by 16? Because if this equals 0, right? We would have to subtract this over.
Oh.
And then divide by the 16. Do you see what I mean?
Yeah.
Okay. Try that in your calculator. Make sure you can get this, okay? 1.54 seconds. Oh, so you want to take, I'm pretty sure Connor did. No way. So I can move that over and then whatever. Okay. All right, next. How far does the ball travel in the horizontal direction? I even said horizontal. I usually don't do that. How far does the ball travel? We are looking for x. Well, what do we plug in for x? Which t value? Okay, so at the time, 1.54 seconds, the ball hits the ground. So if I plug in to the x equation the time of 1.54 seconds, we should get how far the ball traveled until it hit the ground. $26.4. 499? Okay. So how far it traveled, we needed to know when it hit the ground so we could plug that into our x equation. Okay? Now, if we look at our calculator again, we have a parabola. It's going to happen every time. You kick something into the air, it goes up, it has to come back down. It makes a parabola. Okay? What feature of the graph would give us the maximum point? The vertex, right? Okay. So when I ask for at what time will the ball reach its maximum height, I want the time of the vertex. Okay. Now, Eli, you're saying cut that time in half. Why would that work in this example? Okay, would that work if I was 5 feet from the ground when I kicked the ball? No. Since we start at the ground and end at the ground, we could take the total time and cut it in half. But if you start 5 feet in the air and then it hits the ground, is that going to be a symmetrical parabola? It is not. So I just want to remind you of something that you did back in Algebra 2. The vertex is negative b over 2a. Do you remember doing that?
Yeah.
That'll just be a nice shortcut for you. So yes, we could cut the time in half, or we could use negative b over 2a to get our time, because that would represent the vertex. Okay. So what's negative 30 sine of 55 divided by negative 32? Can someone punch that in your calculator for me? Interesting, exactly half of what we started with. Okay.
No, I'm not getting frank.
Okay. My last question, I want us to find the maximum height of the football. Think about it. What is the maximum height of the football? First of all, do we use the x equation or the y equation? The y equation. And I'm looking for a height, which means we need a t value to plug in that will give us the y value. Okay? So which t value do we plug in? That one. Okay, if this is when it reaches its maximum height, let's plug it in. What do we get? What? Okay, I'm going to hand out the worksheet, and I want you to read